So now I want to take this expression, so 6 minus the square root of negative 32, all divided by 2, and simplify it. I see the square root of a negative number, so I know my answer is going to involve the imaginary unit I. And so I want to plan on writing my final answer in the standard form a minus bi for a complex number. One way you might think about dealing with these problems, so the square root expression might end up being the biggest part of this problem. So you could think about simplifying that square root expression by itself first, and then worrying about this overall quantity. So if I'm going to simplify the square root of negative 32, first thing is to notice, well, I have the square root of negative 1 in there. So you can take what's under the square root and factor it to help simplify. So I'm going to factor off the negative 1. And then I also want to think about what perfect square divides evenly into 32. Well, and keep in mind, try to identify the biggest perfect square that's a factor of 32. And if you're successful, then you'll remember that 32 is 16 times 2. That's the best way to do this. And so now you can take the square root of each part of that product. So the square root of negative 1 is I. The square root of 16 is 4. In fact, I'm going to write it this way first. So this is equal to square root of negative 1 times the square root of 16, times the square root of 2. So this is I, square root of 16 is 4, and square root of 2 is an irrational number. So I'm just going to leave it under the radical. And so the prettier way to write this, the convention is to write it in that order there. But it's multiplication, so order doesn't matter. So the square root expression simplifies to 4i square root of 2. Now let me just make one other quick point about that. So suppose you were thinking, well, what I would have done is factor 32 as 4 times 8. I just want to point out that that's okay too. It does take a little more work. So you want to shoot for figuring out the biggest perfect square that's a factor of whatever you have under the radical. But if you happen to jump on one of the smaller perfect squares, that's okay. So the square root of negative 1 is I. The square root of 4 is 2. Now, square root of 8, here's the thing. So you'd have to keep an open mind that, well, can I reduce that further? And yes, you can. This still has a factor that's a perfect square. So this is I times 2. Actually, let me write that as 2i. And then the square root of 8, well, that's 4 times 2. Okay, so this is 2i. The square root of 4 is 2, and the square root of 2, like I mentioned before, is ugly, so we just leave it like that. Okay, so this 4 right here, we took the square root, became the 2 right here. And then this square root is an irrational number, so we leave it under the radical. Can't make it any nicer than that. And so now you would just have to multiply 2 times 2, so that's 4i square root of 2. So this was definitely a longer path, but you do get there. So don't get too hung up on identifying the largest perfect square, but do note that you save some time. So it's worth really thinking about, okay, is there a bigger perfect square that I can get that divides evenly into this number? And so 16 is the best way to do it, to factor that out. Okay, so I'm going to get rid of this. I just wanted to show you, since 4 times 8 might have been the first thing that popped into your head. Now simplifying this whole thing, let me write it down. So 6 minus the square root of negative 32, all divided by 2. So this is 6 minus, so the square root of negative 32 is equal to 4i square root of 2. Okay, all of that divided by 2. Now, it's important to note that this whole thing is divided by 2. Both parts of that numerator need to be divided by 2. This is 6 divided by 2 minus 4i square root of 2 divided by 2. Make sure you divide both parts by 2. And so 6 over 2, that's 3. 4 divided by 2, that's 2i square root of 2. So this would be your final answer on that one.